Okay, today's lesson will be optimization part 2, which is applied to business and economics. So we'll do one question for this one here. So in business, we would like to maximize profit always. We'd like to maximize revenue. We'd like to minimize the cost. So what's the profit? Profit is revenue minus cost. To find profit, we always do whatever we whatever we get minus whatever we pay. So this is revenue minus cost. We have something called with small letter p, called demand function. It's a unit price. So a unit price helps us to find the revenue. We have something, x is always the number of items. Marginal cost. Marginal cost is the cost to produce the next item. So let's see this example here. A small company producing coffee mugs determines the cost to be modeled by Cx 2400 plus 3.2x plus 0.005x squared. And the demand function is given by this. Find the marginal cost for 1000 items, which means if marginal cost for 1000 items means what will be the cost to produce the next item? A. What will be the cost to produce the next item, which means what will be the cost to produce 1000 first item. So we do C prime x. The marginal cost is the derivative of that, which is 3.2 plus 0.010x. So the marginal cost for 1000 means I substitute 1000 here, 3.2 plus 0.1 1000, which is equal to 13.2, which means marginal cost is 13.2, we say, per item. That's marginal cost. Second question is find the production level which maximize profit. We are given cost. We are not given revenue, but we can find it. My revenue is Rx, which is the number of items is x multiplied by the demand function, which means x times 6 minus 0.002x, which is 6x minus 0.002x squared. This is the revenue. So once we have revenue and the cost, we can find the profit. So the profit is capital P, which is revenue minus cost. My revenue is 6x minus 0.002 x squared minus the cost. I can subtract the cost. When I subtract, I change everything to the opposite sign. 3.2x minus 0.005x squared. I can simply collect like terms here, or I can even derive to make it easier, if I don't want to add. The derivative is, this will be 6 minus 0.04x minus 3.2 minus 0.01x. I collect like terms here, which will be 2.8 minus 0.014x, and this must be equal to 0. So in other words, to find profit, maximum profit, the marginal revenue must be equal to the marginal cost. So I solve this one here. 28 is equal to 0.014x. Therefore, x equal to 28 divided by 0.014, which is 200. So it might not be practical, but we get maximum profit when for at 200 items. Okay, so that's typical examples of optimization for business.